I want to talk about external networks and how to integrate them using native BGP into OVN. We will not focus today mostly on how to do this with neutron. There are people working on some kind of neutron integrated product, which I don't know too much. But we'll focus more on the OVN feature and how you could use them, just to see what's possible. We want to quickly take a look at how external networks are generally set up and what they generally are. What's the idea of using them with BGP and how this would work? I guess that's a quite known setup that most of you would be familiar with. You have compute nodes with VMs, you have virtual networks on top of that, you have virtual routers, and then either maybe you have some kind of gateways, maybe you don't, that are in some way specialized for handling internet or provider network traffic, which then bridge out the overlay traffic to the physical network. If we take a look how this looks in OVN, we have a logical switch named intern, which would just represent the network you have in your normal project. Whatever exactly this is, but this is what you would give out probably to your users. You have a logical switch port for the VM. You have a logical switch port that then connects to a project router. This project router is then also the virtual router you have in your normal project, which has a default route to some external network, and which also does DNAT and SNAT if you have floating IPs, or just SNAT if you use floating IPs there. To the right, you have the public logical switch, which is just basically your provider network, which has here a local net port, which goes to the outside. And here a logical router port that's then scheduled on these different gateway clusters, and which does HA and all that magic stuff. If you take a look more on the local net side of things, assume that we have these two gateway chassis, gateway 1 and gateway 2, connected to some kind of switch, and which is then connected to some kind of router. Being at a layer 2, layer 3 switch, we don't care too much about it. And basically we have a large stretched layer 2 network on this public network. Failover is then more of a route moves from here to here, GHOPs are sent out, and the network fabric is then responsible for delivering the traffic to the responsible gateway chassis. So, depending on the size of that, you might or might not really like to have such a large layer 2 network. Especially with things like large broadcast domains, with the need to have, or the problem to have potential flapping and GHOPs being sent from multiple chassis for the same router. If they are flapping in one or the other direction, maybe blacklisting on the switches depending on how they are implemented. All of this is maybe not ideal for large or external networks. For small ones, it probably works. Also, currently the only way to implement any kind of dynamic routing was basically the OVN BGP agent that existed upstream. But that basically works outside of OVN. It tries to use the information that's available in the southbound database to derive what routes should be advertised towards the network fabric. But it isn't as knowledgeable as a native OVN component. It can only guess based on the southbound content. Also, if you have a gateway chassis that uses multiple interfaces, you need to use some kind of bonding. If you want to connect it to different switches, you need to use some kind of proprietary technology on these switches to do bonding across these. So, to think about how to do this with more dynamic routing, we can do another level of inheritance. We still assume that a normal project network exists here to the left and is connected to this logical router, but there was just no step. We still treat this logical switch public as the external network, maybe from a neutron perspective, but it is no longer a provider network, it's purely virtual. It's just integrating the external side to all the different projects. And in between this logical switch public and the logical switch public for real, which then really goes to the outside, we introduce, obviously, magic. Let's listen to something. This logical router magic, which then basically takes the default gateway IP on the public logical switch, so it's the default gateway for all these routers. And it has then per individual interface of each individual gateway chassis logical router port. So you can bind this individual logical router port. So you know this logical router port represents not just any IP address that can move, but this is actually bound to this one interface on this one chassis. That gives us knowledge of where we can route things through. Because in the end we will need to learn for each interface which ports are available or are not available to enable things like failover in case the switch fails or cable fails or whatever else. I also included the options that you would need to set, but they are later in the slides as well, and you will get the slides after the whole summit, so you also don't need to necessarily take close-up pictures of it. And if we then take a look from the local net port again, basically we have the public logical switch port, which is freely movable. We have by the logical router port of the connection from the project router to the public network needs still to be pinned to a single gateway chassis, because it is doing that. It needs to be able to do connection tracking, at least for the source NAT scenario. For the NAT and SNAT scenario, you could probably distribute it, but that's then more a thing of future. We then have the magic router, which is also distributed everywhere, and then we have these logic router ports, which are pinned on this individual chassis, or if it would have multiple NICs, we would have multiple logic router ports. So these then go, if something egresses here, it will go out through this NIC to this switch. If it egresses here, it will go out through this NIC to this switch. And you can then basically set up BGP peerings between these and these. There's a feature in. Alright, let's first take a look at this. And how does it end up? We will have no longer a stretch layer 2 network, which is nice as long as you're scared of layer 2 network. We no longer need bonding because we can model these NICs as separate logical router ports, which means we can learn separate routes from them, we can train them differently, do failure management separately. And failover from, or failover of a logical router, of a project router, now means we move the ideal route to this router. We move it from one gateway chassis to the other, which means we should announce the route differently, but even if traffic increases on another gateway chassis, OVN will reroute the traffic. Egress traffic as well, it will use whatever the magic router has currently learned as best route for this traffic and send it out through. So you can easily do planned maintenance or even non-planned maintenance. You can just move the logical router port of the project router, and OVN is then responsible if it reconciles fast enough to send the traffic over. The network fabric wouldn't necessarily need to know that anything happened at all. It would be ideal if it knows, because you just like stop sending traffic around without need. So what's in this OVN release that includes that for 25.03? We can learn route from Linux VRFs. We can advertise routes from Linux VRFs. Either we advertise from the magic router the whole network, so we advertise the /24 from the example or something like that, or we advertise individual host routes for NAT, for the router IPs, for maybe a logical switch port you have connected, whatever else. The OVN controller will check if the backing port is bound locally. So for NAT, if it's the logical router port that's bound locally, for logical switch port, if this logical switch port is bound locally. And if yes, it will adapt the priority of the route in the Linux VRF. So you will have a possibility to differentiate these two things, and then maybe say I do AS path prefending if I have bad priority, and I don't do this if I have a good priority. So traffic will naturally tend towards the chassis which has the shortest path from the OVN perspective, but it has the possibility to ingress over the other paths. And we also have support to redirect BGP and BFT packets to a logical switch port. So basically you speak BGP to the IP address of the logical router port, but the packet never ends up at a logical router port. It's getting redirected to a logical switch port that can then be in a Linux VRF again. And FRR can listen to it. Let's quickly go through how to do this right now. As you get this afterwards, you should also use it. So obviously you need the inverse. And I included a few neutron instructions in there, but a lot of this will go outside of neutron. You will need the external network. That is not a provider network. That's basically the LS public from the example before. In OVN, we need to then create a magic router and connect it to the public network. We need to set a few options on there, so that dynamic routing is even enabled, that we will redistribute the net addresses from there to the Linux VRF, and also to have a name for this VRF, because otherwise OVN will generate a random one for it. We need the public for real logical switch port. And then for each individual link we need to do a bunch of things, because we need to set up this LRP-LSP combination along with a logical switch port to bind a BGP session to. And basically that's all this and in the end, if you have a project network, you create this project network as normal, you create a router, and then there's the need to remove the option chassis value from this logical router and set a gateway chassis or a chassis group on the logical router for this guy. Because neutron will detect, like, I need to do NAT, but I don't have an external network where to pin this to, so I will pin the whole router to chassis. That's in this case not what we want, and I guess that's something that maybe the upstream neutron feature will make easy. And at this point you should dynamically see the NAT routes being propagated at least to the Linux VRF, and if you have set up something to use the VRF to use the outside, you should also see it on your upstream switches, routers, whatever. Yeah, and just a note that you might need to, depending on how the VRF, how you maintain this VRF, OVN can create it for you, you can create it for OVN, and OVN will then use it. It's something you're free to choose. Depending on that, you might need to take a look how this works. Yeah. Main future work, there are people working on integrating this with Neutron and also integrating this with deployment toolings. I'm not sure what exactly the state of this is. Maybe somebody from the audience knows, otherwise we all don't know. We have still the inefficiency, so if you have egress traffic from OVN, it traverses the project router, it then comes to this magic router. The magic router will most probably have learned a lot of default routes from each individual link, and it will do ECMP on them. Even though maybe one of these egress links is local to the chassis, this processing of ECMP selection actually happens. So maybe you go to one gateway chassis and then it redirects to the other to actually go to the outside, which is not ideal. It will still work, but it's not ideal. And there needs to be upstream work to prioritize basically ECMP routes that are local to the currently processing chassis, because that's just more efficient to do. What's also happening upstream at the moment, in case you're interested in that, but it's not something I'm involved or I've tried out yet, there is EVPN support also for this to even potentially stretch the actual networks. And I think that's it for now. And if there are questions, I guess we have at least 10 minutes of time or 15 minutes.
So, if I understand correctly, OVN via OVN controller is propagating routes to your Linux specific VRF.
Yeah.
And then you have to set up some error to put these prefixes out
Yeah.
the provider.
There was the discussion to actually natively integrate BGP or something like that into the OVN controller, but then maybe somebody wants to speak OSPF and then the whole fun starts again. So the idea was that everybody can, or every peering tool can work with Linux VRF, so let's just use this kind of interface.
And there is no need for another OVN that wants it anymore. There is really one OVN right now.
This is more than one OVN and not a, let's say, creative setup of having a separate node on someone all on the same chassis.
So if VM is directly connected to a public network, so the traffic will have to cross the gateway chassis, right? So it won't be able to be routed from the hypervisor directly. Right?
Or you have to have peerings on each hypervisor to the external network, but then you have a lot of logical router ports, and I'm not sure how good this was.
Yeah.
But it would be an interesting thing to see what happens.
So it's more for when you have no distributed fault links.
That was the initial use case that we had. For the rest, I guess we need to see what kind of optimizations we might need to make this more realistic to easily do.
Is it possible to announce a whole tenant network, for example, IPv6?
Let's go maybe quickly a lot of slides back. Not so many slides. So basically, what we announce. So basically, what we will announce here is either what this logical router directly knows as static routes or as connected things. So we can announce if you have a static route in there, we could announce it. We could announce this /24, or it could announce an optimized version of this /24 where it announces individual host routes depending on what like connected LRPs or LSPs have. So if this magic router has a static route to the individual tenants, which it would need in this case, then you can announce this to the footprint. There were also plans to like synchronize this in some kind of way, but I think they have not yet made it upstream because otherwise you always need this static route, which is also not so great.
Okay.
And if there are no more questions, then I guess have a fun. Next up is Angela. No problem.